Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, I meet up with Mark Berger of Siemens to learn all about their ET200SP Motor Starter. Mark, thank you for coming on the Automation Podcast. I know we tried to do this last week. We had some technical issues, so I really want to thank you for not only coming on, but also for rescheduling when we had those technical issues. So really appreciate it. I know this is it's not Siemens' first time on the show, but it's your first time on the show. And I'm excited to talk about the ET200SP Motor Starters. You guys were kind enough to send me one. I haven't even set it up yet, but I'm looking forward to getting it all set up. But before we jump into the content, could you take a minute to introduce yourself to our audience?
Well, hi, I'm really excited to be here, and thank you so much. I've watched your YouTube videos and I've listened to your podcast often. And my counterpart, John DeTellum, said, "Hey, I need you to get on there and do this." So I'm really excited and a little starstruck, having a little bit of geek spasm talking with you. My name's Mark Berger. I'm an application consultant with Siemens. I've been with them almost 17, working on 18 years. I'm with the Circuit Protection and Controls business unit. I cover a majority of the United States. Pretty much the best way to say it is the west of the Mississippi. I cover supporting all of our technical sales folk, and then also doing applications and also doing some proof of concepts. We do a lot of stuff in the lab, and I have my own lab here where I reside, and we do a lot of work for customers, helping them do proof of concepts. What I'm going to cover today is the ET200SP Motor Starter. So a little bit of tribal knowledge with Siemens. If you hear the terminology ET200 or ET, anything with ET in front of it, that means it's going to be in a remote I/O application with like a S7 1500 I/O card. That would be just a 1500 I/O card. But if you're going to use that same form factor in a remote state, then you would see it saying that it's going to be an ET200 MP. And so that would be the same card, but in a remote state. But what I'm going to cover today is motor starters. These are going to go up to 12 amps. They come in the form factor of direct online starter or full voltage non-reversing, and then come in reversing up to 12 amps or 5.5 kilowatts. This is your complete starter. It does short circuit protection. It does overload protection, and within a 30 millimeter width. It can talk Profinet, Profibus, Ethernet IP, and Modbus TCP. And it's an integrated monitoring. It has an integrated monitoring applications, so we can monitor current, monitor voltages available, and then in most applications we can go up to safety levels, where we have a safety motor starter with SEAL 3 or performance level E, and that is standard off the shelf with a encompass or partnered with a safety PLC. And then you can see that these motor starters can go up to 400 volts in Europe, but here in the United States, they can go up to 480 volts.
You know, I want to paint a picture for our audio-only audience. And so if you're not familiar, if you have not used Siemens and you're not familiar with the ET200SP, I want you to think DIN rail mount, distributed I/O, slice I/O, point I/O. A lot of vendors have I/O in this form factor. It's extremely user-friendly, color-coded, easy to use, removable terminal blocks, the whole 9 yards. But then when we put these starters on there, now the starters are much taller than the standard ET200SP modules. So you may be thinking to yourself, if you're watching, how do they fit a whole motor starter that can do 480 volts into a little I/O module? Well, it is actually, I'm going to just say rough numbers, looks twice as tall and twice as wide. But it fits right onto the end of the rack there, and allows you to take your existing distributed I/O and put motor starters right on it. On that bus. So I just wanted to paint that picture for our audio audience. And my apologies, Mark, go ahead.
No, you're fine. That's great. You're spot on. They're roughly about twice the width of an I/O card and then twice the height. What's giving the height is where you bring in the line power to the starter, and then also your load comes out at the same terminal block. So this is a central wiring for it. There's no other terminal blocks or anything else to wire it to. unless you would rather do that. But we have the terminal blocks that are available that come with it, and you're able to wire your line and load right there next to the starter. Now, the key I want to point out to this starter, what's special about it, is that you can have three ways to start a motor: cross the line, kind of a light switch; soft start, which it uses solid state electronics to ramp up, and then it closes a contactor once it reaches full speed. And then when you want to stop and ramp down, you have it using solid state, and you can control the ramp up and ramp down. And then also variable frequency drives, VFDs. The ET200SP starter is kind of sits in the middle of a soft start. It sits in the middle of a soft start and a cross the line starter. What it does is that it cannot control, you cannot set the ramp up time. It is 80 milliseconds ramp up time, but it's using the same solid state and dry contact setup as would in a soft start. So this unit can do it can do up to 10 million cycles.
Wow.
And it will not break the power or turn off the motor across the contactor. It's only going to use the solid state devices for it. This also plays into is that the form factor for reversing and non-reversing are the same size. So this helps out with a size in your panels, reducing footprint. And then also, if you go down the road, let's say you start out initially in your project, yeah, we're going to do forward on this conveyor belt. And then as it goes down the road, you kind of figure out, uh-oh, guys, we need to back this conveyor belt up and maybe dump it off to a different one. And so you can exchange the full voltage non-reversing with a reversing starter with no changes to the terminal block. All you have to do is change the hardware scheme in the PLC, and then of course you have accessible to all the bits and bytes for turning it on reverse. And then you have the functionality of the short circuit protection and overload already built in, and you had not to change any of the terminal blocking or any of the wiring. All you had to do is change out the unit, and then of course into the program that you're using. So again, this hybrid motor starter, it has a little brother named that's called 3RM1. It's a smaller one. It only goes up to 3 horse, but we want to focus today on the ET200SP. Again, it's the switching of it gives you 10 million cycles due to the fact that you're not breaking power over the contactor itself, but using the solid state application with it. Here's just a brief overview of them. We're ranging the sizes for non-safe or standard motor starters, direct line. There's 5 current ranges, ranging from 0.1 amp to 0.4, 0.3 to 1 amp, 0.9 to 3 amp, 2.8 to 9 amp, and 4 to 12 amps. And this is again in reversing and non-reversing applications and safety applications with safety integrated level 3 or performance level E. The terminal blocks that come with it, they are some a little bit of choosing of how you want to go about doing it. The terminal block, the main one that you're going to pick at the initial motor starter in your rack, is going to have the ability to land your load wiring there, L1, L2, and L3. These starters can do single phase. So if you notice there in the PowerPoint, there's just an L and an N in parentheses next to L1 and L2. So we can do 230 volt or single phase 120 if you need to. And then up above that, you see T1, T2, T3, and then your facility ground, and then 24 volts. That's the first terminal block. And then once you get that terminal block put into play, then you can group the power sections. And we'll look at the next terminal block. We can group the power sections to where now you can run up to as many starters, adding up the current draw, only landing the T leads on that terminal block. So what this does is it reduces wiring in your panel and gives you a little cleaner installation. And then what it will do is those terminal blocks can add up to 32 amps. And then you have to start another terminal block with the L1, L2, and L3 leads. So the key point to pull away from these terminal blocks is that we're reducing your wiring, and then reducing or making a cleaner panel. And then you're able to group the motor starters together. So if you do need to e-stop or remove power from them, then you have 4 or 5 conveyors that you're going to shut down that section. Then you just remove power from one terminal block, and then the other ones will follow because you're removing the power from that grouped motor starters.
I mean, that's a good feature, and that is a feature of Slice IO or like ET200SP IO. Most of the other guys is they allow you to group your IO modules together. So all these are running off this power supply. So we bring in the power once, and now all of them share it. And it's such a time saver and such a wiring saver. And to have that in the motor starters is awesome too. And you said the limit was 32 amps, I think?
Correct, 32 amps. You can add up as many terminal blocks to it, or motor starters to it, and then once you reach 32 amps, then you'll need to add another a new what we call potential. And I'll show you where the terminal blocks here in just a minute with configuring this in TI Portal. One of the great things about the starters is the reduction in footprint and then reduction in wiring to help your panel be a little cleaner and easier to troubleshoot and so forth. Now note also that I can intermingle the safety with the non-safe, and you see that there's terminal blocks that have an F-D1 with an M. That's your safety power that you can remove for those and be able to put it in a safety circuit of kind of removing the power so that that motor starter cannot turn on and go forward, but all the other ones surrounding that motor starter continue to work.
Now, this 24 volts, this is specifically for the electronics inside of the motor starter itself?
Correct. Yep.
Okay.
That's exactly right. And that's how it keeps running. So in this case is that when you remove or do a disconnect of the L1, L2, and L3, the 3 phases coming in, you still have the card powered up and you can get diagnostics out of it, letting them know what's going on in it, even though that you remove the power for the motor itself, which is very valuable for quick diagnostics.
Yeah, typically when we have an external motor starter somewhere else in the panel, we want to use the auxiliary contact to know if it truly is closed or open. But here we will have the electronics still live and kicking, letting us know, hey, do I have line power or not?
Right. And that means the diagnostics continues to come and let you know when things are resolved or you've turned things back on and so forth. I have some customers that use this in their lockout tagout ventures of how going about taking away the power from motors that they're going to work on.
Excellent.
All right. Well, I'm going to exit from the PowerPoint and we're going to go on to TI Portal. Now, quickly, I've opened up Portal and your listeners have seen you use this and go forward to it. So I'm just going to jump to a couple of things. I've made already a project for ET200SP, and I'm going to switch over to Portal View. Oh, I apologize. I did not open it. Let me quickly open that real quick.
Yeah, so while we're opening it, anybody who wants to see how to use this, I cover this in detail. I got a bunch of videos up, and we've also had John on and Lewis on to look at different features of TI Portal. So if this is the first time you're seeing this, check out our previous content. We've covered it really in a lot of detail. Go ahead, Mark.
All right, wonderful. So I've already added a programmable logic controller in here, a PLC. This form factor, and we're going to go to devices to see what's in the project, devices and networks. And it's going to pull up the PLC that I've added, and I'm going to zoom in a little bit so you guys can see it. And so we've gone in here and a little too close. There we go, back out. So I've already put into the project a PLC. This one here, this PLC here, I'm not sure if you guys have covered it, but this is the ET200SP form factor PLC. It's the Slice IO, but it's a 1512, a 1500 CPU built into a form factor where you can put Slice IO to the side of it. What I'm going to do next is that I'm going to add and come over here to my hardware config, and I'm going to add distributed IO and go with the ET200SP. And first out of the gate, we have to have an interface module and what protocol we're going to communicate. I'm going to grab Profinet, and then I'm going to go with the standard Profinet interface module. I click on it, right? Go with the latest and greatest, double click, and then it's going to put it in here into the network view. So this is the overall view. Back out just a little bit more. And then what I'm going to do is go in and configure all the hardware for it. So I'm going to keep it real simple. Here's the interface module. You got a 2-port switch built in so that you can do a star topology, ring topology, however you want to do your networking. I'm just going to go quickly grab a digital in card just for kicks and giggles. And then we'll go grab a digital output card for kicks and giggles. So we've already built that up. Now I'm going to go to the motor starters. And we come right down here to motor starters. And I'm going to just let's do one direct starter for today's demonstration and go with the 4 to 12 amp. Double click there. Put that in. And then I'm going to go do a reversing. Oops, sorry. Go to reversing. And let's do the 4 to 12 amp there too. Now I could continue on adding as many motor starters as you'd like. Again, monitoring how much current we're drawing. So if we have 2 starters here, they're going to max out. Right now, the terminal block is going to handle up to 24 amps. So we're approaching that 32 amp maximum. And then that's when we'll need to put in another terminal block to allow the L1, L2, and L3 leads, or the line leads. Now, what I'm going to do is click here and bring in the properties of it. And if you notice, what we have here is that down below is what we call the potential group. And this is the key thing is that we're going to enable a new potential group. And that means that if you look, that just changed. That means this is the terminal block that's going to bring in the L1, L2, and L3, and then also your T leads going to that motor starter. And then this guy, if I click on this guy and I go to basic parameters, whoops, sorry, double click on it. Basic potential group here, then what I'm going to say is use the potential group to the left, meaning get your motor power from this guy here in this terminal block. And that comes back to the PowerPoints that I showed right here, is that I'm using this guy right here as my first potential group. And then I'm using this guy right here, who's going to get his 3-phase power either from the left or the right. And he's going to associate himself to that initial potential group. Now we could have gone on and added another one of these guys and created another potential group. But this, for now, our just application today, we're just going to stay with having one. Now notice here that it did pull in, zoom in just a little bit. When I changed the potential group, it added those 2 terminal blocks for the 24 volts, because this guy's going to get the power also for the motor and for the electronics in the starter from the left. And then this is the finale, if I could, Shawn, the ooh and the ah here in a minute, and a little bit of the geek spasm over this, is that we're going to generate the IO tags for this motor starter automatically. So we'll show that in just a minute. But once I grab this guy here and look at it, you can now come underneath this motor starter and go to the basic parameters. Here's where you're going to put in the full load amps of the motor, your FLA off the nameplate of the motor. Here's where you're going to change it to 3-phase or single-phase motor. Here is your overload. So you have your trip classes. And notice that we go up to trip class 10, 5 and 10, because 5 and 10 mostly are for simple conveyors, fans, not in a pump application, because what you're doing here is that this trip class is going to limit your delay time on your overload. And so usually it's a low inertia load, meaning that a fan or an unloaded conveyor and so forth. And then here's your pre-warning if you want to send out a bit, letting them know that you're getting close to your full load amps. And then how do you want to act and react to the overload? Now, again, I want to emphasize this starter here has your main disconnect for short circuit. You can rotate this guy. It has a lockout tagout that you put on it, so you can lock out and tag out individual loads. And this is your disconnect. And this handle here rotates, and it rotates all the way out to where that the motor starter is completely disengaged from the back of the terminal block. And then that gives an extra set of visual inspection that you've removed any type of power to the motor, because the starter is disengaged from the backplane that the terminal block creates. And then if you continue to rotate this guy, it will remove the starter completely away from the terminal block itself. And that's how we'd interchange it for the reversing or non-reversing if you needed to. All right. So a little bit of other little details within this guy is that we have blocking current. That's for some little deeper. And then we have limits. You can put in here your high and your high or low. And then also we can do all types of asymmetry and then your inputs also to it. One thing that's not shown in here is that if I go back to my PowerPoint with this guy, if you look quickly, there's a little terminal block right here. It also has, not required, but an accessory, a little terminal block that you can plug in the bottom of the starter, and then you can hardwire a handoff auto right here if you needed to do it at the panel that you're working at. Instead of interfacing, having the PLC be in charge, you can set a bit here telling the PLC, hey, I'm going to do a local stop start, and you could wire that up right here locally. This, again, is just an accessory. It's not required. But in the PLC programming, you can go in and let it know that when you plug this guy in, here's how I want it to act and react for those inputs that you're going to use. And then the field bus interfacing, ground fault, group warning diagnostics, how are you going to talk back to the PLC and how it's going to react and give you diagnostics for it. So everything's set up properly. And now I'm going to go back to the network. And then I'm going to grab my little port here, click on the Profinet port of the PLC, drag it over and drop it into the ET200SP. It's going to make the connection, say everybody's good. And then just for giggles, I want to see what the IP addresses are for it. So here's the little purple button you push, and it releases the IP addresses. Now you're welcome to double click on this guy and go in here and change it here, or you can come down here and change it here if you'd like, but for today's discussion, I'm going to just leave it alone. Now, the next thing, and this is the finale of the presentation, if you forgive me a little bit of fireworks discussion here, the finale, I'm going to come here to PLC tags, and I'm going to show all tags. Notice that I have no interfacing tags to address the I/O points, the inputs and outputs. And I'm going to detach it from there, drag it over here. And if you envision, I can go up to 30 of these motors, 30, 35. I can go up to 30 of these motors, conveyors, little fans, etc., etc. Well, that's a lot of tags that you've got to type in and then make sure you got the right I/O addresses and so forth. But I'm going to come right here to this guy, and I'm going to come down here to, scroll down, I/O addresses, and I'm going to check this little box. Boom. It just created all of the tags for that entire motor starter. So I'll go out here. Here it is, I/O about that are not required from that little accessory block. Here's your motor current. Here's your manual and local mode. Here is all the tags for that motor starter. Now I'm going to go back to the second one. Click on this guy and come here to I/O addressing.
Now, before you do that,
Uh-huh.
can you change the name? Because it has a very long name by default.
Yeah. Now, here's one of the keys I want to point out. Let me zoom out just a little bit. With the diagnostics, these words here mean something. This is just not for a pretty nameplate polling. This actually means something. If something goes wrong here in this rack, it will start the CPU automatically, and the diagnostics will start building the error stream or the diagnostic stream. So let's say that this shorted out and it tripped. Then it's going to grab this title with this and then tie it to the PLC_1. And in your HMI, if you have an HMI with alarm, that's what it's going to say in the alarm, PLC1/IO device_1/ let's see here, DS4-12A HF, and that's what it's going to say. Now, if you want to change that, you come in here and you want to tie it to, let's say, I'm going to say conveyor 1. Oops. Now I've changed that. And then I can come over here and I can call this, go back up here to the device, I believe. Nope, project title. And I'm going to change this to fan 1.
Excellent.
Okay, now I come back to the IO tags. And there it is, fan 1.
So the ones that we had done previously automatically renamed all the tags.
Exactly.
Us,
Anywhere in the project. Anywhere in the project at the HMI, if you're pulling it in some other PLC that you're using, it will change those. And that's the power of portals, using that one database for everything. Is that this can be done instead of doing a search and replace. All you have to do is come here to the tag database and or to the actual hardware and change the name, and it will automatically do it for you. That's the power of it. Now, I did a project back early in the early 90s, or late 90s, and I had 35 motors that I was doing on. And I wish I had this back in the day. This would have been such a time saver. Instead of saying, hey, I got 2 weeks of creating the tags and then doing all the IO, making sure I assigned them to the right IO points. And you see here, it automatically does it for you. It would have been such a time saver. Now, understand that it automatically, so if you look right here, input 84.4, so that's my motor current. If we scroll up here, the rack is ready, or that motor starter's ready as input 83.0. You're saying, well, where did that come from? Well, when we drop that in to this guy, it already assigned the parameters for it. And if I go over here, drag that out, you can see that here's the IO addressing when we dropped it in. And notice this name changes this name right here. So now you know that the IO addressing starts from 83 ... to 86. It's your input. And then your output's going to be 75 ... to 76. And that's your output. And then again, here's the type, gives you a little more description. Here's the type and so forth. So if you need to look and verify. Now I can come back over here and I can, if I don't like PLC 1 and I can redo this guy, I can rename this one main. And once it does that, IO device, fan, and I apologize, I meant to do this. Let's change the IO device. We're going to right click this one. And what some of my customers do here is that we go in here and we call this guy the cabinet that they're in. So let's say that we're going to call this one main cabinet. And whoops, I apologize. I clicked on it and bumped it. There we go. So main cabinet. Now they know that that IO rack is in the main cabinet, and we go here to the tags, and there's main cabinet _ fan 1.
And this is nice because unlike an IO card, where a TIA portal has no idea what you're going to wire into it, this is a motor starter, so it knows what it knows what the inputs are. It knows what the motor current is. It knows all that, so it can just put those tag names in there for you automatically. And of course, you can change them if you want to, but but when you use the automatic tags, now you have this structure that's the same for every starter you use in the system. So it's really cool. And if anybody's interested, if you haven't used Siemens, you want to know more about that absolute addressing, you can check out previous shows on that. We kind of go into that in gory detail.
Now, this is the cyclic data. So this is what's getting acquisition. For you Rockwell users, this would be the implicit data. And I'm right, Shawn? I'm saying it right?
Yep, you got it.
So this is the cyclic data. And then with this starter, there is an acyclic data that we can use, and that's a little deeper dive. But what I'm trying to get at is this is just the standard data points that we're going to serve up cyclically to the PLC for usage in there. But then there's deeper data that you can get from the motor starter that you can get. You can get the last 5 trips if you wanted to know. Maybe your operator comes up and sees that the motor's tripped it keeps tripping, and he wants to show the maintenance guy that when it tripped and what the description was, then that's an acyclic event, and we can suck that out of the motor starter and display it on the HMI to give them a list of what was the trips for that motor starter and the time date stamp. So really, this is the kind of the grandiose of it. Now, what I wanted to also emphasize too of this is that functionality of doing the automatic tag generation. This piece is the same thing if we went in and did our motor starter management system, which is called Simicode. It automatically has automatic tag generation. And if we put in this project a soft starter, it has the same functionality of automatic tag generation. Nice. So I'm just showing you one facet of using one type of form factor for motor starters and getting your motor turning. But in our, as I stated, with soft starters and with our motor management system, Simicode, for Rockwell users, that would be your E300. For Schneider, it'd be TSYS-T, or for Eaton, it'd be a C445. That's our counterparts to that. We have automatic tag generation on both of those units also, in addition to the ET200SP.
Nice.
So key thing to take away from this, guys, is quickly, you're able to program them and get going quickly. You don't have to worry about doing any loop checking because the PLC and the motor starter itself have addressed the IO points. So I know back in the day, I fat fingered something and I'd put in I85.4 instead of 84.4. Mm-hmm. And so I'm fighting my code, trying to figure out why that motor's not working right. Mm-hmm. Yep. So with that, this is automatically done. So that's a reduction in engineering time because you know that that's been put in play. And then again, reduction in panel footprint and wiring due to the fact of the small footprint and the ability to wire it up. So Shawn, that's the kind of the quick and dirty for it, and show everything for these ET200SP motor starters. I hope this is helping you guys see the value and the real-time engineering efficiency that this provides with your TI Portal users and all the application guys out there in the field.
Well, Mark, I really appreciate you coming on covering this. I really want to, as 2023 goes on, I want to cover more of motor controls type products. I mean, there's a lot of products there that are fall into your bucket that I know the audience would love to get updates on. And this ties directly into my world of PLCs, HMIs. So really appreciate you coming on and giving us, not only going over the hardware, but also giving us a tour of using it inside of TI Portal. I think that was very effective. I feel like I can go plug mine in right now and set it up and be going now in a couple of minutes. So really appreciate you coming on the show and giving us this tour.
Thank you so much for your time, and I truly appreciate the opportunity.
Well, I hope you enjoyed that episode, and I want to thank Mark for taking time out of his busy schedule to come on the show and bring us up to speed on the ET200SP Motor Starters. Now, if you did enjoy this episode, please consider giving us a like and a sub, and if you're listening to the audio-only edition, please consider giving us a 5-star review. That really helps us find a wider audience and find new vendors to come on the show, and thank you to all of you who have already done so. Now, if you want to follow me or get in touch with me, you can do so over at automation.locals.com, and you'll find all my PLC, HMI, and SCADA training courses over at theautomationschool.com. With that said, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.